Hello guys, welcome to this video. Here we'll be, exploring how to run Cloudnative Postgres in the Kubernetes way. That'll be the first challenge of Explorers World, second data on Kubernetes challenge. It's the first challenge of Explorers World. We'll be trying to install PostgreSQL clusters in Kubernetes, and we'll be using Cloudnative PG for this. So Cloudnative PG is the Kubernetes operator. An operator is basically a package with its own custom resource definitions, etc., etc. If you're someone who's new to the world, do not worry. It might take time, but you'll be able to understand all of this. Cloudnative PG is the coolest way to run your Postgres cluster on Kubernetes. I froze for a moment. I would have said Kubernetes cluster on Postgres. So that's not the way. It's to run Postgres or Kubernetes. So all of the parts of running a cluster is automated. You need not worry. You can easily run a cluster. So now I'll be jumping into a tutorial where I'll be installing this operator in a Kubernetes instance in Killacoda. So there we go. Okay guys, here we are at the Killacoda website itself. We'll be having a brief walkthrough of how to get the Cloudnative PG operator installed and how to get it running. And now let's dive into it. So you can go to my profile, it'll be Killacoda Abhijith Ganesh. You'll have the link in the description. It'll also be there in the GitHub pages, so you need not worry. Now here we'll be going through the Cloudnative Postgres operator. So make sure you click on this and not on this because this is part 2 of the challenge. Now going through this. So this is the first part of the challenge, all right? You will be having the second part through which you will have to, bring your own application and connect to the cluster. That will be the second part of the challenge. That is completely, unguided. This will be somewhat of a guide. So stay tuned. The guided version will come later. So be prepared for it. Now, let's get started with the operator itself, right? We need to install the operator. So you can install it using Helm chart. I'm going to install it directly because it's a matter of convenience for me. So let me say kubectl apply f paste. So a couple of CRDs will get applied out, right? You might be wondering what a CRD is. So let me show you what all CRDs are there right now. Get CRD. So if you pay attention here, there are CRDs which are relevant to PostgreSQL class.cnpg.io. So a CRD is basically a custom resource definition. I'll be explaining with the glossary terms in the next page. A CRD allows us to, grant custom resources and template them in a certain way. For example, a cluster is a template here, if you pay close attention, and we can grant 500 megabyte or 1 gigabyte of space. So it is a way through which we tell the Kube API, listen, we're going to have a custom type, and for this type, all of these specs are allowed, these many types are allowed, and so on. Now, other important terms, PVC. Assume the entire setup to be a pi, all right? That is the persistent volume. A PVC is basically a piece of the pie. So a pie is usually granted to you. It's made through a baker or you get it in your home, whatever, right? You already have the pie. You already have the persistent volume. A volume claim is basically a small request that is made. A CRD, again, we just went through it. It is an essential part of this operator. It basically grants custom resources. And coming down to a pod is the smallest operating unit. It's not the computing unit. An operating unit, because see, in a pod you can have multiple containers and these containers can have their own service. So the containers are the smallest computing unit, whereas the pod is the smallest operating unit. Now coming to the Postgres terms right here, the first one is the Postgres instance. The Postgres instance is basically a Postgres server through which you'll be accessing for reading and writing data, right? You can also modify, so I'll put that under write. So you can read and write data through your Postgres instance, and a primary is basically a Postgres instance that works both in read and in write mode. Now let us go and apply this manifest If you do not understand how this works, it's completely fine. As you're getting more experience with CRDs, you will understand how a CRD is made, how they're applied, etc., right? Now, for this example, I'll be using a shell called Vim or VI. You can use Nano, for example. So let me use VI. So I'll call it cluster.yaml, and let me paste the code and I quit. Now, it is on us to apply this file which we just created. So we need to tell the Kubernetes API to, have these amount of resources dedicated, have a certain name, etc., right? So to do that, we'll apply it. We'll say kubectl apply f cluster.yaml. So we are telling Kubernetes to apply this file, converted it to JSON, apply it to the API, and give a certain amount of resources. So now let us wait for 35 to 40 seconds because the pods right here take time to initialize. If you pay close attention here, it takes times to initialize. So wait for a couple of seconds, probably a minute. You should wait. Okay, here we are, the cluster example is running. So if this is running, you should be able to see 3 clones or 3 instances which will be spinning up. So cluster example 1 is spinning up, and this will take a couple of seconds. So you need to wait for that. It will take roughly about 20-25 seconds. So you need to be patient. Now, if you pay attention here, cluster example 1 is running, all right? We can now check for all the services. Now, let me explain what we're trying to do here, all right? So, here we're checking out the services because we are trying to find out what all services exist and what all pods exist. So, if I run kubectl get pods, we'll be able to see all the pods running. Now in the Kubernetes world, pods are ephemeral, which means they can die, they can be replaced, and they cannot exist. You can't be dependent on pods because pods are temporary. We need to depend, or we need to be connected to them through a service. The service has a cluster IP and it has a port. A cluster IP is internal. You can port forward it and make it external. All right. So let's say kubectl port forward, because they need to be externally accessible to to connect into them. Otherwise, we can't use our Postgres cluster. It wouldn't make a lot of sense. So let us put forward our cluster example here. And oh, oops. So it will say port forwarding from so on. So now if you have done this, if you stay till here, congratulations, you've gotten your first Postgres cluster running on Kubernetes. You might now be wondering, Abhijith, all of this is cool, but how do I access it? You got me there. You can access it if you know how to bring your image here, or if you know how to bring your application here. You're expected to bring your own web app or any application that connects to Postgres and connect to this port. So if you know how to do that, if you're some Python developer, simple stuff, if you know how to use SQL connection, you'll be adding your port there and that will be your connection. If you're a Rust developer, the process is pretty much same. You add your 5432 port there. If you're an Express developer, there must be an alternative, not an alternative, there must be a connection string somewhere. I'll add a reference repo down in the description. That is the second part of the challenge, so stay tuned with it. I'll add the walkthrough once we're done through the due date. But for reference now if we type get svc, the external IP will show none here, but if you can access it, if you bring it through here, you can port forward it here with Killer Coda. There are options, you need not worry about it. You can configure that. So now that this is ready, let me show you how you can submit all of this. All right. So we've typed a couple of commands, and all of these commands will have to be stored in a certain way. To do that, create your own GitHub repository. I've created mine here. For example, it's called Killer Coda example scenario. You can call it whatever you want. You need to create a shell script with all the commands. Like for example, we had a command to search for the services, right? So we put get services. Now we also had a command to port forward. That command is here. Similarly, all the commands you apply can be added to a shell file, and this repository link can be shared with us. Oops. This repository, this repository link can be shared with us, and the sharing process have been added in the previous video. You can check it out. You need to create an account with the Explorers World DoK, which is Explorers World. Yeah. So you need to add your submission here, and you need to log in, go submit a report. Once you do that, we'll go through it, we'll review it, and we'll increase your level and points according to that. So stay tuned, do the challenge, and the rewards for the challenges are this. Again, so here we are at the Explorers World. I hope you like the rewards, and these challenges are the starting point of your new learning curve. You're set to learn a lot of things and to learn how to run databases and other data relevant services on Kubernetes. This is the way to go. We started with Postgres because Postgres is the most used database across planet, and you are very aware of how Postgres is used. We'll be having another operator coming soon, so stay tuned with us. I hope you like this video. Leave your suggestions to us in the comments and let us know how we can improve on this. Thank you. Have a good day.